Today our topic of discussion is delta P. Delta P is not just a number, it's a hidden pulse of iron making. As we know, delta P signifies the resistance to wind. And once resistance to wind crossover the critical limit, process become more inefficient. So let's explore how this pressure difference shape everything inside blast furnace. Now coming to this slide, which shows that delta P or dP is the pressure difference between the blast pressure at the tuyer and the top pressure at the furnace throat. Simply put, delta P is equal to blast pressure minus top pressure. It tells us how easily gas can flow through the furnace. So we can say that it is the easiness of the gas traveling from tuyer to top. If the wind struggle to enter, iron making suffers. As just now we have discussed this also. Why does delta P matter? Now question arises that uh, what are the circumstances in which delta P struggle? So it's a vital indicator of gas flow resistance. And we know that a stable delta P means a smooth body descent and efficient reduction, because gas will be uniform and a symmetrical overall profile will be there. So if it fluctuates, the entire process become unstable, impacting productivity and fuel efficiency. So overall we can say, once delta P is disturbed, then furnace is totally disturbed. There is a lot of process upsets will be there, and these signify the inefficient operation. So consequently, this thing will be getting reflected in terms of higher coke rate, asymmetric conditions, abnormal circumstances like slips, channeling, bleeder lift, and so many things. So now coming to the and thus in this context, it is quite essential that we need to know that what are the cases and what are the factors, what are the circumstances which affect the delta P. So we have categorized especially part 1 and part 2, and we will see that in part 1 we are going to discuss the mainly the fine and moisture, how they take part in disturbing this delta P. So let's look at how the raw material affect delta P. Like first we are considering the fines. Fines are a teeny particle and block the gas pathways, and they come from undersized material or breakages inside the furnace due to low temperature breakdown properties of the material. So moisture add another challenge. Uh, it cools the furnace, number one, and consume extra coke for evaporation. Thus, by both delta P and material, our efficiency become reduced, and especially when moisture mixes with these fines, then they create a insulating layer in between the burden and the cooling system. So this impermeable layer also hampered the overall process immensely. Now coming to the second part, as we discussed that in second part, coke and ore quality hamper the delta P very badly. So coke and ore quality are critical, and hence weak coke breakdown, forming fines that block gas flow. Poor ore similarly, like sinter that disintegrate or pellet that swell, also disrupt the reduction very badly. These issues, these all issues raise the delta P and the force the furnace to work harder. And once furnace work harder, then it is inefficiency of the furnace. It's signaling inefficiency, trouble, which is just waiting for blast furnace steam. Now coming to this slide, which is about how we charge the furnace is important, especially in context of delta P. Now, when we charge the furnace, the fines tend to settle near the wall as a natural granulometry and trajectories. Now, forming this impermeable zone towards the wall, and when it comes under a moisture, it becomes more impactful in not allowing the gases through the walls. And there is a improper heating of the burden also. Now, this improper bin management also, our uneven charging can cause a scab, hanging, and pressure spikes in totality, as we know. So, all these factors together can create a really big problem. Even layer thickness affect the gas distribution and heating also. Now coming to the internal furnace dynamics, as we can see that inside the furnace several factors influence delta P, like high liquid level. This also is a very important aspects or parameter which can affect delta P. Similarly, slow burden descent is the consequences of high liquid level. We can say the cohesive zone also getting resisted by the gas flow, and a hot furnace shift this particular zone upward is also causing a erratic movement many times. uh, Channeling where gas finds a shortcuts leads to inefficiency and the pressure surge. So we have seen those the problems, the parameters that contribute to the furnace inefficiency and pressure surges. Now coming to the what happens, we coming to the reasons of what happens when delta P goes wrong. We see these many reasons emerges when these problems are running for a long time, and we could not able to take a corrective measure to eliminate it or to take care of such type of abnormal situation. We see hanging, sleeping, poor reduction, and even equipment damage are also the consequences of such act. But we can control it through the monitoring, better raw material, thermal adjustments, liquid drainage, and wind rate control. And in such situation, wind rate control is going to be a magic wand, because this is the quickest act that blast furnace team can take care. So even a controlled sleep can also and why this is important, because even a controlled sleep that can reset the furnace from scratch, because entire layers gets changed, and again it need to create the layers from beginning, and that is also time taking, and in order to refurbish this entire layer, this will also take time. So overall we can say there is a lot of loss associated with such type of